So Daniel, I just dropped the live stream link in the chat. You're welcome to get going whenever you like, and I'll hang on for a little bit in case there's any issues.
Okay, super. Thanks a lot. So I would just wait like 3 more minutes and then start.
Okay, sure.
Okay, thanks a lot. So, hi everybody. My name is Daniel Szegő. We're gonna take a look on today with Hyperledger Budapest and together actually with Hyperledger Sweden, how you can run Fabric on Kubernetes. So this is gonna be something as a non-informal session. I will share a couple of ideas and a couple of challenges if you want to run Fabric and Kubernetes in the following approximately 1 hour. So in case you are not so much familiar, this is actually Hyperledger. Hyperledger is a project from actually an incubator from Linux Foundation, mostly focusing on consortium blockchain technologies. So if you coincidentally not familiar with the idea, then just a second. What we talk about is basically this project. So in Hyperledger, having a couple of consortium blockchain technologies, and actually one of the oldest consortium blockchain technology in the Hyperledger project is Hyperledger Fabric, which was basically originally started by IBM and by Digital Asset as well. So that's Hyperledger Fabric. It's one of the oldest, and I would say one of the most established project in the space. This is a community session. So basically it's like, just free, pretty much any content regarding related to Hyperledger. and mostly consortium blockchains as well. So I'm running basically Hyperledger Budapest, and then thanks for the Hyperledger Sweden guys. This session is co-hosted by Hyperledger Sweden as well. So thanks a lot for that. So it's like cooperation community session, both from Hyperledger Budapest and Hyperledger Sweden. So after this brief introduction, what I'm gonna do, I will just summarize a couple of ideas regarding Hyperledger Fabric. So in case you are not so much familiar with the topic, or even if you're familiar, but perhaps, I mean, it's just better to have something as a 5 minutes summary before plunging very much into the details. So what we basically talk about is something which is called consortium blockchains. So in consortium blockchains, I mean, you got blockchains, so you got peers in your blockchains. So these are like the peers. But basically the main idea for consortium blockchains that your peers are running actually at different companies or kind of enterprises or regulated institutes. So if we talk about these peers in a consortium blockchain scenario, we usually mean some kind of an organizations running these peers and some kind of an organizations wanting somehow to make some kind of a business network, somehow collaborate with each other. There are many frameworks of doing this. As I mentioned, one of the oldest is basically Hyperledger Fabric. Hyperledger Fabric is so from an architecture and infrastructure point of view, it's not the simplest use case. This main idea that we got somehow peers with organizations and of course transactions running into the system that are basically validated by these organizations. So this whole concept is pretty much distributed, and let me put it that way, it is structured in a way that basically it can cover many different enterprise scenarios, which is on the one hand good, on the other hand, it's not so much, I mean, lucky, because you have to deal with the complexity if you want to do anything with Hyperledger Fabric. So if we regard Hyperledger Fabric infrastructure or architecture, there are 2 points of view that should be considered. One is the so-called Hyperledger Fabric physical architecture. So what you see here basically is the physical architecture. We got 3 main elements in Hyperledger Fabric. On the one hand, we got the peers. The peers are practically storing the ledgers and simulating a kind of smart contract, which is called chain code in Hyperledger Fabric. And then it's basically a pretty much so Dockerized infrastructure, meaning you got like a couple of microservices in the peers as well. So these are the peers. We got something as ordering service. Ordering service is responsible for ordering the transactions. So practically you got something as I would say atomic transactions coming into your ordering service that somehow negotiates between several components. And as an output, you got practically a block with the order transactions in a pretty simple way. So that's one of the second components. And we got something as certificate authority. So the point is that this is a consortium or enterprise blockchain technology. So it's, I mean, if I just go back to my sketch pad, it's not exactly the same as a public blockchain. In a public blockchain, you can always have one more peer. You can even download the source code, set up your own peer, and then somehow attach or join to the network. This is not the case in consortium blockchain technology. It looks that way that we have practically consortium members, and then basically a new member or a new node can't join just at will to this consortium. There are certain governance processes, so practically most other parts of the consortium or members of the consortium should basically admit or should basically allow that this new peer joins to the network. So as an implication, this is not an anonymous network, but basically all the components that you see here are identified by public-private key cryptography. It's more practically, it's X509 certificates. So basically, all infrastructure components got something as an identity, and then basically ordering service knows that it communicates with the peer, or even ordering service components communicates with each other, and so on and so on. On top, there's not just component identity, but something as TLS as well. It's again a network communication, and we got actually public-private key cryptography and X509 certificates on the customer and rights, people rights or different roles and rights side as well. And basically, all these certificates can be issued. Mostly, they are issued by the certificate authority or more than one certificate authorities. So these are the main components from an infrastructure side for Hyperledger Fabric. We can plunge in more into the details of each components. So as you see, like peer is not just so simple. It's not one component, but it's actually like 3 components that can be set up in different scenarios, having like 2 peers, 3 peers, as many peers as we want. And peer itself contains several components. So like we got the main peer element, which stores basically your blockchain. We got the chain code, which is only the smart contract of Hyperledger for Hyperledger Fabric. And usually we got something as a different database, which might be a CouchDB. This stores the word state. So with this help, we can query pretty fast Hyperledger Fabric state. As you see, ordering service contains a couple of components as well. So it can be configured how your consensus in ordering service look like, how many internal components you have, and so on and so on. And basically, certificate authority is usually not so simple, just having one certificate authority. You can have like 2 certificate authorities for one for the identity, one for the TLS stuff. And then you can even have something as a hierarchical certificate authority structure as well that might somehow reflect your consortium. And of course, you have somewhere here a client. So basically, client does nothing but sends transaction to the system and expects that this transaction will be processed. But in Fabric, actually, client is not so simple either, because it is part of the consensus mechanism. So usually you can't just have any kind of client, but it's pretty much strongly proposed that you use something as a standard SDK for client or gateway at the moment. So that's the physical architecture. Just a couple of words about the logical architecture. So in the logical architecture, we got something as organizations. And the organizations, like, if you want to have a business case between several organizations, then these organizations are the abstract entities for this modeling or for this consortium. Organizations usually somehow cover some of the rights, access rights, or summarize some of the access rights that are available for members of the core or users of the given organization. We get something as channels. Channels are practically individual blockchains. So, the infrastructure itself is capable of setting up not just one blockchain between several organizations, but 2 or 3 or any kind of blockchains. Basically, channel is a way of privacy as well. So, in this scenario, you see we got like 4 organizations. Channel 1 is set up between organization 1, 2, and 3. And we got a second blockchain, a second channel as well, which is set up between organization 2 and organization 4. So basically, in this way, the transactions are separated physically as well. So like organization 4 won't get any of the transactions or any of the state change from channel 1. So that's the basic idea. And of course, channels got something as chain codes, and basically organizations can have many peers communicating with the network. So this is kind of a logical architecture for Hyperledger Fabric. And if you do something with Hyperledger Fabric, I mean, the best way is usually starts with Fabric samples. I mean, Fabric samples itself is complicated, so it's not so simple. But the point is that it's simpler than any other source, I would say. And then besides, it is maintained relatively well. So I mean, like we got like the 2.3 version, if I'm not mistaken, or 2.3.1 version the coming weeks. So you will find pretty soon the latest test scripts and latest examples here in Fabric samples as well. So if you work with Fabric samples, or basically, I mean, most of the samples on the internet, what we get from the infrastructure side is something which is Docker Compose. So these are Docker Compose and Bash scripts. It looks like this way. This is just Visual Studio Code fragment. So we get usually something in the middle as a core component, which is a Docker Compose file describing your major infrastructure. And we got basically a couple of different bash scripts that starts your network, initializes stuffs, configures stuffs, and so on and so on. We have something as crypto materials that can be either configured with Cryptogen. That's a built-in tool in, I think it's not in Fabric samples, but it's an official Fabric tool. It is not exactly proposed for production scenarios. So for production scenarios, you should usually use directly a certificate authority. But I think most of the Fabric samples are configured with Cryptogen. It's just because, you know, it's just much easier to create your certificates and whole certificate structure without having to worry or fighting with the certificate authority. So again, we get something in a standard crypt that starts your network, that brings up your Docker containers. It starts your containers. It usually creates a channel or several channels. It installs one chain code, and basically at the end there's something which is a test. So I mean, test is usually you initiate a transaction or you query your chain code. That's practically the test for your environment. So in case you still did not see any Fabric samples, so I must say, I mean, this is the basic idea, but in details it's way more complicated. So you should be really, like knowing a little bit on about Docker and bash scripting if you want to go or plunging deeper into the topic. But again, so as a major element, there are some Docker Compose files, bash scripts, running up your network, starting your containers, creating your channels, installing the chain code, and then initiating transactions or queries on your installed chain code. So basically, on a high level, it's so simple. So then what we gonna try to do is have this structure and make some brainstorming how you can put on top of Kubernetes. Okay, so I mean, basically your standard scripts. Again, I mean, Fabric samples is, I think, not the, so these are samples. So you should not necessarily have Docker Compose behind, or you should not necessarily use directly these scripts. But from a practical point of view, I think it's just much better to start with these scripts, because I mean, most of your examples on the net basically are based on such a scripts with Docker Compose and bash scripts. So it's just much better to start with this thing than having any other way of going to Kubernetes. Of course, if you're actually a very much Kubernetes and Hyperledger Fabric professional, you might even start brainstorming just skipping actually this Docker stuff and going right away to Kubernetes. But I would not propose it for the first round unless you feel that you're very much professional. So what we're gonna brainstorm on, how we can bring this structure to Kubernetes. And again, it's gonna be a very short introduction, unless if you coincidentally not so much familiar with Kubernetes. So just 2 slides about it. So Kubernetes is basically a container orchestration platform. So I mean, if we take a look on these scripts, I mean, Docker Compose is cool on a playground level, but I mean, Compose is not even something which is enterprise ready. You can theoretically build something with Docker Swarm, but Kubernetes brings much more possibilities into the play. So this is like a container orchestration platform. You got your containers, or we call them here pods, and it offers a couple of different scenarios, like it runs your pod. It runs your pod on a distributed environment. It monitors your pod. You can add something as resource quota. You can size up, size down your containers. You can configure things like, based on the network load, based on the incoming transactions. You can do something as automatically deploying more containers, more pods to the network. So like automatically scaling up or scaling down. You can have some support for automatic deployment, management, and a lot of stuff. So I would say, Fabric in Docker and Compose is something which can be regarded as the basic containerized, infrastructure. But if you want to deliver in a real life application, then Kubernetes is a good way for that. Just a couple of other stuff. So it's open source. It is supported by the Cloud Native Foundation and by Google as well. There are many extensions and variants. So like, for instance, like actually OpenShift, if you might as well heard about, OpenShift is built on Kubernetes, for instance. So let me put it that way, that you will find Kubernetes in a lot of companies and scenarios. So it's such a choice that might investigating if you want to run Hyperledger Fabric in a real productive environment. The other thing is actually, so basically, if you take a look on the internet, you find most of the Fabric examples for Docker Compose, of course, but the second choice is Kubernetes. So the second stack technology that you find basically examples on a community basic is Kubernetes. So this is the other reason it's worth looking a little bit more in details. Kubernetes has some special concepts. So these are like containerized infrastructure, how you build up your containerized infrastructures. These are like pods, services, volumes, labels, selectors, node replica sets, config maps, secrets, stateful sets, and so on and so on. We won't go very much into the details in these concepts. I will just mention how you can use them in Hyperledger Fabric. So the next one is basically, next slide is something which is more on a Kubernetes infrastructure itself. And then, so basically it looks that way. You got like 2 components. One component is your master. It can has 2 nodes as well for high availability reasons. So you can have 2 master nodes. Even if we speak about like blockchain, you can have actually 2 master nodes for each consortium member. So it's even more complicated. But anyway, so the master node in Kubernetes supervises your network. So basically, it makes sure that your network behaves as you described. I did not mention, but Kubernetes uses something as a declarative concept. So you just declare what's the expected state of running the network. So like you say, hey, I want to have like 2 containers, actually 2 pods from this kind, and then please make sure that I always have two containers or 2 pods from this side. And then it's the responsibility for Kubernetes master making sure that you have always these 2 pods. And then, for instance, if there's, for instance, a hardware failure somewhere, very much deep into the infrastructure, then Kubernetes master node makes sure that your pod will be migrated to another physical infrastructure, which is not faulty. So everything, or not exactly everything, but actually the idea is that most of the things happen behind the scene absolutely automatically. And you get something as working nodes. Working nodes are like, like physical machines, for instance, that actually runs your application. So like in Hyperledger Fabric, what can be brainstormed basically, like if we, so this is one farm, for instance, or one Kubernetes farm. So, I mean, of course, one question is like, if you have your own, your whole blockchain network on one Kubernetes farm, which might not always make sense because it's then pretty much centralized. But anyway, let me just imagine the idea. So in this situation, like you get like 3 working nodes. So your Hyperledger Fabric components will run on the working nodes of Kubernetes. Like I can run like one peer on node 1. I can run one peer on node 2. And then I can run like one ordering service on node 3, and one ordering service on node 2, and one ordering service on node 1, and so on and so on. So then here on the one hand, your Hyperledger Fabric infrastructure will be high available as well. Actually, it's high available on the application side as well, because, I mean, if you like 2 physical nodes, so again, you can imagine just 2 physical nodes as two physical computers, or 2 physical data centers, for instance. So for instance, if you got like 2 peers on two physical machines, then if one physical machine gets faulty, then your network might run further. I mean, it depends on your endorsement policy as well. Again, you can configure from an application level high availability in a sense that you get like the ordering service, and then the ordering service is distributed on the nodes. So if not all the nodes goes down, just like one, your rough consensus might work despite. This is one thing. The Kubernetes specific stuff is of course that basically your master node will recognize actually that one of the physical working node goes down, and it will migrate your Hyperledger Fabric infrastructure to the other ones, to the working ones, if they are available and if there's enough resource. So in this sense, it is again like a 2-time high availability architecture. I wouldn't go exactly into the details very much. You get like kubelet and then master database and API server and stuff like that, but they are not so much important in this discussion. So this was basically the infrastructure, and we reached the point that, hey, cool, I got something as Hyperledger Fabric, perhaps a couple of Docker scripts, and then so let me just deploy somewhere on a Kubernetes cluster. So what do we do? Well, so first I would have a couple of considerations before going very wide and deploying something somewhere, especially in production environments. And this is just a general consideration. So if we see like Kubernetes or stuffs like that, they are usually associated with DevOps. And basically DevOps and even Kubernetes, so on the one hand, it provides something which is a pretty cool thing. I mean, it's a containerized infrastructure orchestration. But on the other hand, it has some special ideas that can't be very simple put into the practice with the blockchain. And so basically, let me just put it that way. So Kubernetes is a containerized infrastructure, but the ideas behind were not designed for blockchain. Okay, so you can put it basically to Kubernetes, but you should pay attention on some special stuffs. And the first thing is scaling. So what does scaling mean actually in a normal environment? It's like, I got one front end, and I run my front end on a containerized infrastructure. So this is my front end. If I can write. Okay, let me just, so this is my front end. I just succeeded to write like TF, but it's the front end. So supposing that I run it somehow in a Kubernetes environment, what I can do, basically, I can scale it up to 2 front ends or even 3 front ends. So what does it mean? It actually means that supposing I have something as a big load on the system, I can just scale it up 1 more front end, and then basically my load will be distributed behind these 2 front ends, and the whole system will be running faster. And then I can have basically a third one as well, and then I can say, hey, that's pretty cool. So I have a third front-end system up and running, and then basically my incoming traffic will be distributed automatically with a service and load balance practically on free front ends. So my whole system will be running much faster. So that's the idea from Kubernetes. That's one of the major, design goal. So what's the problem with that in blockchain? So the problem is that blockchain doesn't scale exactly so, because what you have in blockchain, you get nodes, and it looks that way. The idea of distributed consensus is that your transactions that are coming into the network are validated on all nodes. So that's basically the idea. It's not exactly works that way with Hyperledger Fabric, because it's just more complicated, the whole infrastructure. But there are elements where you can expect exactly this behavior. So this is your blockchain. And then what you get here is a transaction. So if you have a transaction, practically or indirectly, because of decentralized consensus, it will be validated on all blockchain components. So this will be validated here, this will be validated here, and this will be validated here. That's one thing. So what happens if you just say, hey, let me just scale up the network, let me have 1 more node? Then basically what happens is that your blockchain will have 1 more node, which means that your transactions will be validated in 1 more node, which practically means that it will be more secure and more decentralized, but it will be slower. So basically, you get exactly the opposite in a blockchain network in terms of scaling, what's expected, for instance, in Kubernetes. And the point is here that basically blockchain scales for security and decentralization and not for performance. So this is one thing which is very important. Because if you speak with guys who are professional with Kubernetes but not blockchain experts, they expect exactly the same thing. Hey, we got front ends, we can scale up, we can scale down front ends, pretty cool. So why can't it work exactly the same way with blockchain? Well, so first there are 2 things. Blockchain doesn't scale for performance, doesn't scale for speed. Blockchain actually scales for decentralization, and it scales for security. So the more node you have, the more node will validate your transaction. But of course, the whole system will be slower. So this is one big thing, one big difference. The second one is it's just usually not so simple to scale up your network with 1 more node from a technical perspective, because it's just not so easy that, okay, let me just create one more node. In Hyperledger Fabric or in any blockchain, these nodes should be attached somehow to the network. So like in a public blockchain, you can pretty easy to attach this node to your network, but the blockchain should be synchronized. So it's just, in front end, if you get a front end application in Kubernetes, you can upscale your application with 1 click. It won't work with blockchain. Even if this 1 click creates your new pod or new container, it's still not part of the network. In a public network, you should download the whole blockchain. That might take actually days. In Hyperledger Fabric, this node should actually join to the network officially, which might have some other challenges as well. So these are two very important things. I wrote it that here. So increasing pod number is easy in Kubernetes, and then you can actually, so you run your Hyperledger Fabric in Kubernetes, you can very easily increase your pod number, but you won't have, I mean, on the one hand, you will have some error messages, of course, and then on the other hand, you won't get the same effect what you expect actually. So these are two big differences. The third one is the smart contract. And then, so if you have like Kubernetes, then you have usually something which is DevOps as well. And the idea from DevOps is that, yeah, so we release like pretty fast, even on a daily or I don't know, 4 hours basis, which is pretty cool. And then, so why actually Kubernetes is integrated with a lot of different DevOps stuff, so why shouldn't we do it? Let's do it, let's integrate it. And this is again something which is a design principle of blockchain, which contradicts DevOps. So DevOps has absolutely different design principles in this sense. And then this idea is the smart contract. So smart contracts were not designed actually to be deployed very often. In Ethereum, practically you can deploy smart contracts once. So unless you implement some fancy upgrade strategy, but basically it looks that way that, you know, I mean, that's blockchain, your smart contract is designed to be immutable. So like in Ethereum, the normal case is that you can deploy it once. That's all. It's more easy, or it's more simple in Hyperledger Fabric because you got the chain code, and the chain code can be actually upgraded, but it requires that all of your consortium admits, so approves it. So it wasn't designed. It was designed that basically your smart contract or your chain code in Hyperledger Fabric is like, I don't know, if you want to update it or upgrade it, then basically you have to go to each company of your consortium, and each company has to approve it, that you can deploy this new chain code. So it's again not something which can happen on a daily basis unless something very wrong. So basically integration with like CI/CD pipelines is difficult, and then not just from a technical perspective, but sometimes because usually sometimes it just doesn't make sense. You know, it just doesn't make sense that you deploy like on a daily basis a new chain code because that's not what the whole system was designed for. Going a little bit more into the details, if we speak about like running Kubernetes on Fabric, there are like three different components from a governance general point of view that should be handled differently. In this slide, what you see is basically Kubernetes on the bottom. So you got like Kubernetes, which is your orchestration. Under that, you have something as hardware operation system, virtualization, doesn't matter. So on top, you get the Fabric components. You get like certificate authorities, peers, orderer, and stuffs like that. You get something which is chain code. Chain code is your smart contract. And you have somewhere a client application that communicates with the network. So the thing is that I experienced with is that basically, so people in like DevOps or with Kubernetes competence usually say everything which is running up basically or on the top of Kubernetes is an application. It's like a front end. So you can like, you know, it's an Node.js application, for instance. So it can be handled in the same way as a Node.js application, end of the story. But if we speak about the whole Fabric application, this is exactly the case. And from the lifecycle governance and other things, we should actually distinguish like three parts. One is basically the fabric infrastructure itself. So these are the certificate authorities, peers ordering services, and stuff like that. I call it as fabric infrastructure. Again, from a Kubernetes perspective, this is an application, but from a general like governance perspective, it's more like an infrastructure. So it looks that way. You want to deploy this like once, and you don't want to change this very often. Pretty simple. You have like the Hyperledger Fabric versions, like 2.2. From migrating like from 2.2 to 2.3 is not necessarily the easiest task. Sometimes there are like architecture changes. So basically, these components, which is your fabric infrastructure, behaves as an infrastructure. So you can like upgrade your infrastructure on a yearly basis, but certainly you don't want to upgrade your infrastructure on a daily basis. So again, upgrading or migrating like from one Hyperledger Fabric version to another one might be a big job as well. So it might contain, the point is that you don't know what's different between between your current release and the further releases. So it might require something as rewriting your application, rewriting your chain code, configuring stuffs in a different way, and so on and so on. So from a governance perspective, this part behaves as a containerized infrastructure and not something which is similar to like a Node.js application. The second part is basically called chain code. And again, chain code is actually the application that you develop. So it contains your business logic. But again, so from a governance perspective, it doesn't behave exactly as a code or as a business application that you write. And simply because it was designed in a way that it shouldn't actually change very often. So again, if you want to change, you need to have the approval from all of the participants, which might take actually time, especially in a big like consortium, especially if the companies taking part in the consortiums are actually competitors from each other. Then such a release might take time. And the third one is your client application, and which communicates with your Hyperledger Fabric. So with peers, indirectly with peers, with your chain code and other stuff as well. And your client application is something which can be integrated very well, both in Kubernetes and in DevOps and in any kind of CI/CD pipeline and so on. But this is just this part. This is just the client application part. So let me take a look how we can rewrite actually or implement basically something from Docker to Kubernetes. And then basically the idea is, the high level idea is not so complicated. The details are certainly way more complicated. So we got something even in most of the Docker Compose files as volumes. So what we're gonna do, we're gonna rewrite it. We're gonna implement volumes, Docker volumes, as practically persistent volume claims in Kubernetes. It looks that way that so Kubernetes storage, abstract storage is something which is a two-level thing. So we got like persistent storage storing the real stuff, and then on top there's something which is a persistent volume claim, and persistent volume claim which is embedded practically in your application as a storage. But between these two things, there's like an abstract layer. So you can configure on a Kubernetes side how you can map your persistent volume claims to persistent volumes. You can even set like speeds and other stuffs like that, and the exact storage. So this is like having something which is an abstract storage, that's a persistent volume claim, and having something which is a real storage, which might be like, Google Drives, Google like Cloud Drives or something, or an NTFS storage or something similar. So that's the first idea, that, anything which is a volume in Hyperledger Fabric Docker Compose, you can just re-implement as a persistent volume claim that will be mapped somehow with a persistent volume. You should pay attention, of course, like two things. Like one is sizing. Size of the data can be extreme big if you have like a big production environment. And the second one is which might be surprising, but it is something which is called disaster recovery. And then, so it looks that way. It's not so typical to speak about like disaster recovery in a blockchain system, but as we have something which is a consortium, it might make sense even to speak about like disaster recovery. So there's some proposition which are the folders that should be implemented as basically surely on a persistent drive, and then if you do it practically, then you can restore your system from a backup, your whole system from a backup. It's practically a couple of folders under your ordering container or pod, and a couple of under your peer. Your ordering persistent volume or volume will store the system channel and the system blockchain, and then your peer will contain your channels and blockchains and private data collections and stuff like that. So you should store them in a persistent volume. You should store your certificate authority. It's got practically an internal database as well. You should store it on a persistent volume, and everything which is like a configuration file or certificate, they should not be necessarily stored on a persistent volume, but they should be stored in a persistent way, and then you can recover from errors as well, even in a way that you practically rebuild your whole Hyperledger Fabric file from backup. So that's the first thing, that's volumes. The second one that you got is containers in your Docker Compose. So the idea from containers, you can re-implement as practically. So in Kubernetes, there's one abstraction layer higher. You get pods, and then basically pods can run one or more containers. So here the best idea is usually to have like one pods for each of your container, which internally we run one container, which is exactly the container that should be running. There's one exception, that's the chain code. So chain code is a little bit more complicated because it looks that way. Then in Hyperledger Fabric, if you have something which is a peer, so this is your peer, and then it looks that way, that basically chain code container will be created by your peer as you install your chain code. So this container will be created by your peer. So it has some problems. It doesn't fit very well actually in most of the containers infrastructure. So one way of solving is that you get like one pod, and then you configure in a little bit special way. So this is like one pod. You have to have like one or two special configuration items in your config in a way that your chain code will be created in the same pod where the peer sits, basically. So this is one way. There's another way as well. You can have something as an external chain code container. This is a new component of Hyperledger Fabric from version 2. And the idea is here that, this creation, that the peer container creates another container, it has some security issues that are not very much welcome in most of the operation environments, or some. In some it is not a problem, but so it might come you might find the example that the operation team in the company says, hey, this is such a security bug that it's not allowed to use it. And in that situation, you can have something as an external chain code container. External chain code container looks that way, that you create your container, your chain code, your practically your pod for your chain code as an individual element without a peer, and then you can make after this connection somehow. This is like the external chain code container from Fabric 2. So that's the idea. We got containers. Basically, containers will be pods. We have something as services. It's a concept for Kubernetes. It publishes practically the services of your containers, either to or your pods, either to other pods or indirectly to the whole external or internal network as well. For the external network, you need some other components as well, but basically you need for each pod one service. And then you have something as deployments. So basically for each such a service, you can use one deployment. Deployment practically wraps together the stuffs that you deploy. So like the service and pods, and rolls out, rolls back, or upgrades them if you need it. We usually propose, or I usually propose stateful sets instead of deployments. It looks that way basically, that so with deployments, I mean, deployments are very easy to scale up and scale down. So stateful sets are much more like components having the individual identity. And then, so the problem is, I mean, you don't necessarily need stateful sets, because I mean, if you configure well your volumes, then basically your pod can be restored even if I mean even if you just redeploy it. So it doesn't necessarily should, like, I mean save the state of the pod itself. But the point is that with deployments, it's so easy to scale up and down that usually, I mean, somebody from the operation will have the idea that, hey, cool, let's just try to scale up or scale down. And well, so like, for instance, if you have an ordering service, ordering pods or ordering components have something as an identity. So if you just scale up or scale down naively, then you can get a lot of error messages, a lot of errors as a result. So basically, I use usually stateful sets here. Again, not necessary for saving the state of the pod, but just for the reason that, hey, this is something which is identity. Don't scale up very very fast without brainstorming what's gonna happen behind. So the next thing is something which is config files. I mean, unfortunately, Hyperledger Fabric infrastructure is difficult because you have a lot of config files around. So it doesn't make the situation easier if you use Kubernetes. And there's one other thing, that's your Cryptoconfig. Cryptoconfig contains, again, a lot of crypto files, and it contains a lot of like public, private keys, X509 certificates, and stuffs like that. So there are two ways of putting that to Kubernetes. One is something that you basically copy how it works with Docker. So in Docker Compose, you get like one folder or a couple of folders that contain most of your config files and most of your Cryptoconfig. So what you can imagine is something similar. So you can have something as a, you will have your network somehow here. So these are your pods, like peers, ordering service, and stuff like that. So this is like a peer. This is like an ordering service. And then it would look somehow that way, that so each of these pods will have something which is a persistent volume. So this is the persistent volume of the peer. This is the persistent volume of the ordering service. This is the persistent volume of the certificate authority. And one thing that you can do is that you can set up one persistent volume. This persistent volume is for the Fabric home. It's usually called, I think, Fabric home. If you just take a look basically on the net. So, and then all stuffs will basically read out the things from your persistent volume. So all the config files and all the certificates coming from this persistent volume. So it has some problem, this structure. This is like, let me just call it as Fabric home. Fabric home. So the problem is, on the one hand, is security. So this is not a decentralized way of doing things. The second one is basically something which is, so it's not usually very stable because it's, so the point is that Kubernetes has got something which is a different model for reading and writing your volumes than like Docker. So you have something which is, you can configure that your volume can be read by many different pods, or your volumes can be written or read or written by one pod. That's the two standard models. If you want to set up like a pod, like a volume that can be read and written by many different pods, that's not so simple. It requires some hacking and won't run in a very stable way. The other problem is that, like initializing this persistent volume. So you want to put here all of your config files and stuffs like that. So initializing this Fabric home is not so simple. You can use like something that you have basically a setup pod, and you configure your PVC in your setup pod, and then as your setup pod initialize your Fabric home, you just bring your setup pod down, you bring up your network, and then they're gonna communicate with this Fabric home. So you can do something similar, but again, it's a little bit like hacking, unfortunately. So there's a better way, or more Kubernetes way, but it requires a lot of configuration. And then it looks that way, that you have in Kubernetes something which is config maps and secrets. And config maps and secrets are meant to store such information. You can store like your the standard configuration files from your Hyperledger Fabric in config maps, and then all the config maps is pretty much public. Your secret meant to store actually like password information. So you can put like all of your certificates, private keys, and all of the sensible information into secrets. So this is a better way of doing it. Unfortunately, it requires a lot of configuration. So you can imagine how many files do we have in Hyperledger Fabric. All of the files should be actually imported as config maps and secrets. To do it actually without error is not necessarily very easy. And last but not least, what you get is you get something which is a setup, how you set up your network. This is in Docker Compose, a setup script. You can do something as setup script in Kubernetes as well, but it is not so much the best idea. So what you usually do is you write a job or cron jobs. Cron jobs is if you want to repeat something several times, you get a cron job. But basically, like for simple stuffs like creating your channel, adding anchor peer to your channel, installing your chain code. These are stuffs that can be implemented with a job. So these are the main ideas. I will show a little demo. It's unfortunately not so deep as I meant, and it works only halfly. But anyway, so you will find the code here. I will get a fully functioning version probably end of next week. I can show something already, but it's not fully functioning. So next part will be a demo. And so what I started actually yesterday evening, it's just, I mean, for so many configuration stuffs, it's not something that you can do actually in a half day or in an evening. It's because you have so many different configuration files. But basically what I started to set up a very simple network in Docker, and I started to rewrite into Kubernetes, just to make sure that we see the steps, how you can do it. And so the first one, this is a very simple network. It actually has, so the network structure looks that way. I got basic one peer, one ordering service, one CouchDB, and basically one channel. I don't know how to, but this is the channel, and one chain code. The chain code is the marbles demo. So it looks that way. I got one peer. This is my one peer. This is my CouchDB. This is my ordering service. I got one channel. And basically I have something which is one, I think it's called the dev channel, and I got something which is one chain code. This is the marbles demo that is running here. So that's my whole fun. And it basically looks that way. If we start from Docker or with Docker, the major item is your Docker compose file. So basically it describes your ordering component, your peer component, your CouchDB component. And I got one more component which helps me actually installing everything. This is like a Fabric tools. Fabric tools will be unfortunately deprecated slowly. I think it's already deprecated with like 2.3 or perhaps even 2.2. But despite, I mean, you can still find the versions on the net, surprisingly. So basically, this is a tools to help you configure your network. So what I will do with the help of these tools, this is the setup tools. I will practically configure my networks with the help of this component, with the help of this container. Okay. So this is my code. So what I'm gonna do first, what I have to do first, that I have to generate my crypto material. You find usually something as generate as it looks that way, that in a very simple setup, it creates a Cryptoconfig folder. It generates your crypto material with the help of the CryptoGen tool, and with the help of the config takes gen tool, it creates your config, which contains your Genesis block. That's the Genesis block for the service channel. Actually, it contains basically the channel. That's your channel description, and then there's some anchoring core information. So to generate some of the materials, you should run generate.sh, and again it generates two things. One is the simplest way is the config, which is again these three configuration items. The more difficult is your Cryptoconfig. Under Cryptoconfig, you find, I don't have certificate authority at the moment, as you see. All of the stuff that should be generated by the certificate authority is generated by CryptoGen. So as I don't have certificate authorities in my Cryptoconfig, I have two main folders. One is for peer organization, and the second one is ordered organization. And what I find here is the crypto material for like peers. Again, I have peers crypto material, makes sure that all peer has identity. All peer can practically sign with the peer identity any kind of transaction or internal communication. And I got some TLS communication as well, which is basically here. I get something which is an ordering service. So I have basically one ordering identity and one ordering TLS settings, which is under the ordering organization. So under MSP and basically TLS folders. And on top, I have here users. I have users for peer, and then I have users. These are the peer admins, and then I can have peer users as well. And I can have something which is an ordering service admin, which is located here under this folder. I know it's pretty complicated. I wouldn't go very much into the details. Just one hint, basically, you get these config takes and Cryptoconfig YAML file. These files, I mean, if you generate your Cryptoconfig folder and your different configuration files, and these are generated actually based on these description files. So if you want to fine tune anything, then basically what you have to do is to configure your config takes YAML or Cryptoconfig YAML, and then after that making something which is a generator. So let's see. Let me say that okay, we generated somehow our Cryptoconfig. So the next part is something which is starting your network, and starting the network is simple. I mean, not simple, but if we just want to start, it's simple. What we have to do is just having Docker Compose and bringing up the network, bringing up the necessary components like ordering service peers and so on and so on. What I have after that is the configuration of the whole network. And configuration of the whole network is more complicated. It creates a couple of Hyperledger Fabric commands. So first, what I'm gonna do is that I will create a channel. It has some parameters like name. I have to configure exactly the different parameters for accessing like components in Hyperledger Fabric. So for instance, this command should be executed under the peer admin, if I'm not mistaken. Otherwise, I get an error message. But anyway, so what I do first, I will create a channel. Then I will join to the channel. So after this part, basically, I have something which is a full channel up and running. And as I have just one organization, I will join just with one organization for this stuff. After that, I can list my channels. And there's one more command, which is an anchor peer update. I think it is only required if you have a private data collection, so you shouldn't necessarily run this command. So after having the first parameters, then what we have to do is that we have to install basically something which is a chain code, which has again a couple of steps. So first, what I'm gonna do, I will package my chain code. Actually, my chain code is somehow in my container, so it is accessible from the tool container. So first, I have to package my container. For that, there's a special command. It's a lifecycle chain package. After that, I have to install my chain code. And after that, it looks that way that if I just install my chain code, it's not enough. It looks that way. This chain code should be approved by organization, by all organizations. Again, at the moment, I have just one organization. But if I have like 2 or 3, then all 2 or 3 organizations should approve this this chain code. Or actually, this can actually somehow configured in the config takes.yaml. So this is the normal case that all of your organization must approve your chain code before it's getting live. But as far as I know, there can be other scenarios as well. So you can configure that not all of your organization, but I mean, it's just the majority of your organizations should approve your chain code before going live. So if I approve that stuff, what I do is that I commit my chain code. And if I commit my chain code, then basically it will be available. I mean, not exactly, but it will be installed. And what I have to do is to initialize my chain code. And after committing, it will be available. After initializing, the necessary service objects will be created as well. So after committing, it can be initialized. And if it is initialized, then basically I can run transaction and query on my chain code. So let me take a look how it works. It was still working yesterday evening, so I hope it's still working. I don't run generate because I mean everything is generated, as you can see here. And so let's have something to start. So what you see at the moment, basically the that were the components, the Docker components. That's the CouchDB. That's the example. We get one peer and basically this CLI setup. All were initialized. I just have here an artificial wait time for 30 seconds in order to get, I mean, surely get the system up and running. So after that, the commands are running, as you see. So first, basically, I created a new channel. Second, I joined my peer to the new channel. Thirdly, I just configured basically an anchor transaction, an anchor peer. And then what I'm having now, after that, I start to install my package to the chain code. So this is running. And then after that, there's this life cycle of my chain code. So basically, I committed, I installed, I committed, and then I created basically the chain code. And then I initialized the service object as well at the end. So basically, it looks that way that at the end, we have somewhere that we have a successful chain code invoke. And we have something as a successful chain code query. Okay, so basically that's the whole story in a very simple way. We have the configs, we generate the Cryptoconfig, we set up the networks, which are the Fabric components, we install the channel, and then we install the chain code, and that's the whole setup of the network, setting up of the network. And that's what we should actually rewrite to Kubernetes or rework in Kubernetes. So I started to rework into Kubernetes. It looks that way even in Kubernetes, that we got basically the major elements. So we got like the config transaction.yaml, and we got the cryptoconfig.yaml as well. And we got the generate file as well. And these things are pretty much the same. So I generate all of the cryptoconfig and all of the config files here locally, basically. I don't rerun it again, but you can imagine that if I rerun, then all of the stuff will be generated here. It is exactly the same as in Docker, so I did not innovate much. there can be actually, so like a steep centrics, like there can be problems with like admins. So if you have like, I don't know where's an example for that, but anyway, if you have like admin at example.com or something, then usually Kubernetes don't really like the @ sign. So there might be some hacking that you need actually on the long run. But basically, these structures are almost the same. So this is my Cryptoconfig, and this is my config. So generate is almost pretty much the same. So as a second, what I'm gonna have here, and this is where it's getting complicated. So what I started to do is that I rewrite all of my configurations, or I import all of my configurations to Kubernetes secrets. And unfortunately, so I could not find how I can do it in a nice, automated way. So this is pretty much a manual process. I took a look one by one on the different examples, and then I created basically a secret with some kind of a naming convention that can be recognized on the long run. So anyway, what you can do basically in Kubernetes. So unfortunately, I did not find a way of like, importing folders with hierarchical folder structures into Kubernetes, but perhaps you guys have some ideas. So what I can do, basically, I can import one folder, or I can import the files one by one. So if I just import it one by one, then basically, just wanted to basically, quite sure why it did not work, but let me just try it again. So this is how it looked like. So basically, if I create a secret based on an existing file, it imports into a secret or into a config map. I have some config maps as well. And then basically my whole file will be imported in that way. So after executing like import secrets, what I will have here, a couple of secrets. So these are the secrets. As you see, these are mostly for the different crypto material. And again, so the naming convention is from me. So I just tried it to describe what it exactly means and how it is reflected in the folder structure. So these are like the admin certificates, like the ordering certificates, like the peer certificates, TLS certificates, and so on. These are all secrets. I have here the configs as well, like the channel transaction, like the anchor peer transaction, and the Genesis block as well. So these are again, so you can practically import them in the same way. So if I just import, then it looks that way, that basically this is my channel configuration. This is my Genesis block. Actually, it's pretty much, I mean, doesn't say much, but it is totally readable by Hyperledger Fabric and usable. So you don't have to do much, and doesn't matter how the encoding looks like, because it's just automatically resolved. So this is one thing. And of course, what I did after that, I have a couple of configs that I just have basically, that I did not import automatically, but rather manually. So like, for instance, I started to have here something which is a setup script. So if you have like setup script, you can put into one config map, and all of your such stuffs can be contained in a config map. You can do it automatically as well, but I did not do it automatically. It's just what one config map it contains, like the core YAML, and we got at the moment just another setup script which doesn't do much at the moment, but we can execute it for sure. So having my secrets and config maps, the next part I must do, or I should do, that's the persistent volume claims. So it looks that way again. If I just go back to Docker, so theoretically I should have some volumes here as well. So as you see, I have one volume for ordering service, one volume for peer, and one for CouchDB. So I just replicated it into a persistent volume claims. So I get like one persistent volume claim for CouchDB, one for ordering, and one for peer. So basically that's all. It's more complex, or you can more fine tune actually in Kubernetes than in Docker. So I have like axis mode is read write once. So only the certain pod, certain component can write and read this persistent volume. I have some limits as well, limiting for one storage. And it looks that way. So that's the abstract representation of your persistent volume. Depending on your environment, it will be mapped to certain real storage. So for instance, what I use here is Minikube. Just let me just show it. It's just kube. I think cluster info. So basically, my cluster is running locally. It's a Minikube environment. And then if I just create these persistent volumes, then it looks that way. I do not have neither persistent volume nor persistent volume claims. But if I just create I think that's the name of the file. Yep. So I can't really write at the moment, but actually, let me just show it very fast. So basically, 3 persistent volume claims were created. So I got both the persistent volume claims, and they are bound. So means that basically they are bound to real persistent volumes that are actually stored some in my Minikube. So I got here like 3 persistent volumes as well. Pretty simple. So let me just delete this stuff. So the next step, after having like config maps and persistent volumes, and of course indirectly secrets as well, is to write your components. So basically, I have here like the peer. Let me just start with the CouchDB. The CouchDB is simple. So what I have for CouchDB, I get 2 components. One is a service. Again, it requires that you have a service, so you can communicate with your components actually, and configure how you can communicate with your components. So it's a good idea to have a service. I'm not quite sure if it is needed exactly for the CouchDB, but we surely need it for peer and ordering service. And after that, I have a stateful set, which again might be actually a deployment as well. So basically, stateful set looks that way. It is, again, it's a little bit different than Docker, but basically what I'm describing is that I get a template, how my my whole stuff will look like, that have basically a container which has some environment variables. It has an image, it has some ports, some volumes, and then the volumes are mapped somehow to the persistent volumes. So I mean, the very basic ideas are similar to Docker. It's just the syntax is totally different, and yes, some conceptual stuff is different as well. But again, we have the containers, we have environment variables, we got an image, we got ports, we got volumes mounted. So these things can be copied almost from the Docker Compose file. So like if you just go to Docker Compose and go to CouchDB, then basically I got these two environment files, then I get one volume mounted, and then I got the image, which is the Fabric CouchDB 0.4 and so on. So these stuffs are reflected practically one-to-one. So we got the environment variables, we got here the image, we got here the persistent volume, and so on. Pretty similar for peer as well. Unfortunately, peer is a little bit more complicated. So first I get a service for peer, some ports opening, and then after that I have a stateful set. Again, it can be deployment as well if you want. And then basically after that, it describes again my container, which has some environment variables, which image I use, some ports I use, and the volume mounts. And here getting the things surely complicated, because the volume mounts are coming not just for volumes, but basically from the secrets and config maps that I configured previously. So like, for instance, this certificate which is imported under the following secret name will be mapped somewhere under this folder. And then there are a couple of others. So this is like, I mean, it's a real hacking sometimes to do it in a correct way. But this is how things look like. There's one more different. It's like usually Kubernetes doesn't like dots and long names. So like usually peer 0 is just peer 0 and not peer 0.org1.example.com if you rewrite to Kubernetes. We got here ordering service. Ordering service is similar as well. So we got a service for ordering service. We got a stateful set for ordering service and all the environment variables, and then ports, and with a little bit fine tuning, basically the volume mounts are as well similar than in Docker Compose. Only one big exception is that, I mean, all of these volume mounts are basically mapped not with external volumes, but basically with secrets or config maps elements that I imported previously. So this is how it looked like. There might be some minor difference as well in the environment parameters. So like, I don't know, in peer, I get here like the peer address, which is like peer 0 and port, but like in Docker Compose, this is like peer 0.example.com or peer 0.org.example.com. And you might need some, yeah, exactly. It's something that I should delete because we do not have the external chain code. But anyway, so I would say environment parameters are 90% the same. There can be some differences due to Kubernetes, and then volume mounts should be very similar. The only one big exception is that you don't have these stuffs coming from an external volumes, but you have these stuffs coming from config maps and secrets. Pretty much the same is true for CLI setup. I think I have here just one stateful set, so I did not publish as a service, but the idea is basically the same. So I can start the stuff, but I can't configure everything on that because it's still not working. So if I just say, create, so what's happening? The configured stuffs will be were created. So basically, there's like a CLI setup. There's a CouchDB. There's a CouchDB service. There's the ordering service. That's the ordering stateful set. So basically not deployment. There's the peer service. There's the peer stateful set. That's the config maps that was created. And then I created 3 persistent volume claims as well. So if I just take a look what's running, I will have practically my infrastructure up and running. So I have like a peer and ordering service, CouchDB, and the CLI setup as well. You might wondering, I said basically that CLI setup shouldn't be actually a pod here, but it should be something as a job. From a practical point of view, it looks that way that, so I mean, debugging this whole stuff is sometimes not so simple. So if you have a job, it looks usually that way that job works that way that you create a pod, indirectly a container, and your job runs with that pod or container. So what I usually do for the first run is that I create my setup as a pod, and then I test it and make sure that everything works. And if everything is cool, then it's pretty easy to rewrite this pod as a job, which actually creates that pod and running the whole setup as basically as a job in the system. So I still got some errors, so I can't show basically how you can. So I can partly show something, but basically stuff still don't very much work. So basically I just went into the CLI setup container, and then basically, I mean, similarly, the idea is similar on my CLI setup container. I can basically start having my commands. So at the moment, I just created basically the channel. Then similarly, after creating my channel, I can join my channel. I can create my endorsement transaction. I can have my my package. I can install my chain code, and after that, I can issue some transactions as well. I still have here one error, which is something somebody is wrongly configured, and I couldn't just get it basically yesterday evening. But anyway, so I think you can imagine the idea. You got this CLI setup that support usually all the similar commands. So like create channel, create anchor peer, package your chain code, then install your chain code, approve your chain code, commit your chain code, create your chain code, and then after use your chain code pretty much similarly as in Docker. So I think that was my presentation. Actually, I planned it just for 1 hour, but it's just pretty difficult to get the timing. So I just stopped sharing my screen, and then if you have any questions, then I will try to answer it. I hope you guys have an insight how it looks like actually having like Hyperledger Fabric and Kubernetes. It's not the easiest way of doing it, but it's not impossible.
Hey, Daniel, I have a question for you. When you're setting up different deployments for pods, is there any consideration to take about syncing ledgers between peers that are on different pods?
So I'm not sure what you mean by syncing ledgers on different pods.
Or I
So
guess it's the same deployment, but you scale up that deployment with more replicas. And then if there's multiple replicas of one deployment, and does that peer node have to sync with other replicas?
Okay. I think I having, let me just, I think I have one. I think I have one more slide. Yeah. So this is the chain code deployment. And then it's for two organizations, but I think actually it's pretty much the same for two peers as well. So like two peers, two organization, it's questionable. But anyway, so what you have to do, actually you have to install your chain code on all peers, if I'm not mistaken. So it means that even if you have one organization and two peers, or two peers and two organizations, you package your chain code and you install your chain code. That puts actually your chain code physically somehow on the peer. So as far as I know, it should be done for all physical peers, this install command. The second one is basically approve. You have to approve once per organization. And then after that, commit can be done only from one something. So like one organization, supposing that all of the previous organizations has approved. And as far as I know, init should be done only once as well, as far as I know. But this step is like installing the chain code should be executed on all peer individually, as far as I know. Does this answer the question?
Yes, kind of. Thank you. Sahan's question in the chat says peers should not be replicated, right? Is that true? So should we not be replicating peers at all and just create multiple pods for each peer?
Let me just. So I'm not quite sure if I get the point exactly. So the question is if you mean this installation of the chain code or the whole ledger. So from a conceptual perspective, what you got here, you get here peers. And then ledger is stored on the peer. So you have here one folder in each peer, and your whole full ledger is stored in this folder. So this is your ledger. And it's automatically, so you don't have to do anything with that. Independently, if you have CouchDB, is not necessary as well, because CouchDB stores basically only the state. And this is your peer. And this is your second peer. And you get here a chain code container as well. But your chain code container stores only the code itself. So it doesn't store the ledger. But if your chain code container wants to communicate or gets information from the ledger, then it connects the peer and gets the ledger information. And then it is automatically, as many as your peer has practically each peer stores the full ledger. It's a little bit more complicated because the full ledger of the given channel. So I mean, supposing that you have here one channel which is common for these two peers. It's more from a conceptual level. So it's one thing if you mean the ledger itself, which is the blockchain for one chain code, for one channel, sorry, or if you mean the code itself, which is just the smart contract code, and the smart contract code is stored in the chain code container, but that's created by the peer actually. So I mean, you have to install it actually on each peer. Yeah.
Okay, thank you.
So this is one channel. And again, so this is the ledger. So for instance, I can even show it. So basically on a peer basis, as far as I know, your ledger is stored under this path. It's var Hyperledger production. So if you prepare like backup recovery scenario for Hyperledger Fabric, then make sure that you store this folder. So I just stop sharing and take a look if there's like further questions. Oh. Yeah, so there's one question regarding certificate authorities. So what I did basically, that was a simple version of the whole configuration. We did not have certificate authorities. It's because this Cryptoconfig version simulated for us certificate authorities and generated all the certificates. It has some drawbacks, like I think the certificates are issued for like 15 years, and then you can't revoke them, you can't renew them. And I'm not quite sure how much cryptographically secure are they generated. But anyway, so in real scenarios, you should generate your certificate with certificate authorities. And then you can set up your structure in many different ways. So you can have like one certificate authority for your whole farm, for whole organization. You can have like several certificate authorities, one for different, one for one for each different member of your consortium. And then you can even separate your certificate authorities as one for the main certificates and the other one just for the TLS certificates. So there are many other options, and then it's getting really complicated in this sense. Two certificates, federation. I'm not quite sure if you can use bridge certificate authorities. I think I'm not quite sure if you can use like cross certification between certificate authorities. I think the only supported way is using in a hierarchical manner, in a tree fashion. But again, so to develop a digital health infrastructure for human powers. This is not a question. Okay, sorry, I'm just reading the chat. If there's any question that I'm somehow not considering, just let me know. So yeah, perhaps here for the peers. So I have here just one peer setup basically. Again, this is a very simple one peer, one organization setup. You can replicate the peers if you want, but it's getting more complicated, and then you require more storage. Usually in any kind of live setup, production setup, you have of course more than one peer. That's not a question. But in this simple example, I just had one peer. Okay. So yeah, so chain code invoke will create a new Docker container. That's correct. It's there are two ways of doing it. There's a configuration. I'm not quite sure at the moment absolutely, but basically you can configure that your your chain code, that your peer pod can create one more container inside the pod. It's something that can be configured. It's just one parameter. I just don't remember it at the moment, but it's doable. So then in case it won't be a problem. So your chain code container running on the pod will create your peer pod running, your peer container running in the pod will automatically create one chain code in the same pod. So it's doable. This is surely one way. The second way that I know is that you use remote chain code. In that case, basically we have one explicit pod for one chain code, and then your peer won't create anything basically automatically. It just connects it. So you have to configure that your peer should be aware that you have chain code containers running. But if you have that, it can be a possibility as well. And I'm not quite sure if there's a way that your peer container in your pod creates basically a chain code container which is in a different pod. It's something that I don't know. Perhaps it's possible, but I guess it's not so easy. So let me just take a look basically on the YouTube chat if we have any questions. Yeah, there's one question. Is basically if it is. So I mean, this deployment wasn't based on external builders. It was just the standard way of doing it, and it was based on Hyperledger Fabric 2.1. But it's pretty much the same in 2.2 as well. And it's not external builders. So again, with external builders, you should have some more considerations because there are plenty of config files that should be configured on the peer level. You have to set up at least like 4 scripts on your peer that are controlling the external chain code creation and stuff like that. Then you should make some modification in the core YAML of your peer, and so there are some more options that you should be set. This was just a simple example where you don't use external chain code and based on Fabric 2.1. So, if anybody aware of questions that I did not answer, then I would just give one more second. So if not, then basically that's what I planned in this meetup. It was taking a little bit longer than I expected, but it is usually that's the case. So unless there's more question, I would finish here the meetup. I would like to thank you very much for your time, and I wish you all Merry Christmas and Happy New Year.